Good day everyone. Today we are going to discuss the chapter 3 of building construction, specifically the construction 3D printing. By the way, my name is Rixie Orizo Jr. and I'm going to discuss this topic in this video. But first, let us define what is construction 3D printing. 3D printing in construction, also known as contour crafting or building printing, is what may believe the future construction. The printing of building has a lot of potential advantages when compared to conventional construction methods. There are lower labor costs involved, constructions can be done quicker, and there is less to no waste produced. The concrete waste and failed prints that do occur can be reused as raw materials for printing. This technique can also be used for construction of extraterrestrial structures, for instance in the moon or the planets where environmental conditions are less conducive to human labor intensive building process. In simple words, construction 3D printing is a method for manufacturing construction elements or entire buildings by means of a 3D printer printing concrete or polymer, metal, or other materials layer by layer. And there are benefits and challenges when it comes to construction 3D printing. And those are first, faster construction. Second is lower labor costs. Third is fewer people means more safe construction. Fourth is less material use. Five, new designs are possible as 3D printers can create complex surfaces. And lastly, the method and resulting physical properties of the printed construction elements are not yet recognized by building standards. Next is the scale methods, the humble beginnings. In 1984, Charles Chuck Hull invented stereolithography, a method of 3D printing where designers create a 3D model that is printed layer by layer into solid physical object. The SLA produced involves pointing a UV laser at a liquid photopolymer which makes it solid. The 3D printer makes commonly used in the consumer sector are SLA printers from companies like MakerBot and others, and it was clear that this technique could have applications in manufacturing and beyond, so Chuck promptly took out some patents and found 3D Systems, a 3D printing company that is still alive and well today. How defined Hall defines stereolithography as a method and apparatus for making solid objects by successively printing thin layers of the ultraviolet curable material on top of the other, and it became widely used in rapid prototyping and direct manufacturing. One of the earliest uses of 3D printing was to print tabletop scale models for architecture firms. These models in pre-BIM days, BIM stands for Building Information Modeling, helped the design process, and were valuable tools for both selling and planning building projects. 3D printing was much cheaper way to erect these scaled down models compared to the two-time handcrafted replicas that had been the norm previously. The advent of 3D and 4D building information modeling or BIM largely made the creation of physical models unnecessary, but many firms do still enjoy showing their work of this way. By the 1990s, several organizations began experimenting using 3D printing to produce modular components of full-scale projects. And by 2000s, these applications were in full swing and getting set to transform the entire industry. In just past few years, 3D printing capabilities have grown by leaps and bounds, enabling super practical applications or some practical applications that were unthinkable even 15 years ago. For instance, full-scale practical applications from 2000 to 2016. In 2006, Dr. Berok Kosnevis of the University of the Southern California unveiled the contour crafting systems, an enormous 3D printer designed to literally print building in place, and it works like a desktop printer, but uses a crane to do the printing and concrete as a medium to lay down a building structural elements. A 3D printing system developed by the Massachusetts Institute of Technology uses a large, highly controllable robotic arm to spray materials like concrete via any conventional construction nozzle. Next is the Plastic Canal House of 2014. In 2014, a Dutch firms or Dutch architects set out to demonstrate the potential for 3D printed architecture by building a canal house out of 3D printed plastics in Amsterdam. The project uses a giant crane-like printing arm called Kammermaker, which literally means room builder. This project is ongoing. And one of the examples in the 3D printing canal house in the Amsterdam, as stated in this phrase. Next is the steel bridge of 2015. In 2015, the Dutch 3D printing firm MX3D began printing a full-scale steel bridge to be installed in downtown Amsterdam. When complete, the bridge will be fully functional. It is a proof of concept piece of the MX3D technology, which aims to make steel construction more cost efficient and faster. MX3D is a 3D printing a bridge across a canal in Amsterdam with the support of partners including the Autodesk. Next is the off-grid dwelling of 2016. In January 2016, the architecture firm SOM announced a partnership with the U.S. Department of Energy Oak Ridge National Laboratory to produce highly efficient dwelling structures consisting of a 3D printed pod and combination of renewable solar and natural gas energy systems. While these structures are not yet on the market, they promise to provide a cost-effective means of providing shelter in formerly inaccessible and remote locations, as well as sustainable long-term shelter for disaster relief. As you can see in the photo, that photo represents the 3D printed shelter, includes rooftop solar panels and an integrated battery systems to power the dwelling day and night. And it comes to a companion vehicle that also generates its own power. Next is the Inspire Concrete Mansion 2016. As you can see in the photo, in June 2016, a Chinese company, Wasang Tenda, announced that it had constructed an entire concrete mansion in 45 days. The company erected the building's frame first, placing a plumbing and electrical wiring, and then printed the structure using 20 tons of inexpensive concrete and a computer-controlled printer. The two-story, 4,305 square foot dwelling claims to be earthquake-proof and environmentally friendly. The 10 houses in 24 hours of 2016. In April 2016, another Chinese company claimed to have printed 10 houses in 24 hours. The walls are constructed from a mixed recycled construction material and cement, and the makers claim the homes are both cheaper and more environmentally friendly than the traditional construction. The company also built its own office entirely out of 3D printed modules. Architect James Bruce Gardiner pioneered architectural design for construction 3D printing with two projects. The first Prehab Tower 2004 and the second, the Villa Rosia 2009 to 2010. Prefab Tower was based on the original concept to combine a hybrid form of construction, 3D printing with modular construction. This was the first architectural design for a building focused on the use of construction 3D printing. Influences can be seen in various designs used by Winson, including the articles in the Winson's original press release, and the Office of the Future of the Prefab Tower project also depicts the first speculative use of multi-axis robotic arms in the construction 3D printing. The use of such machines within company has grown steadily in recent years with projects by MX3D and Branch Technology. The Villa Rosia. 2000 to 2010 took this pioneering work to a step further with a design for a Villa Porto Rotondo, Sardinia, Italy, in collaboration with D-Shape. The design for the villa focused on the development of a site-specific architectural language influenced by the rock formations on the site of along the coast of Sardinia, while also taking into account of the use of the panelized prefabricated 3D printing process. The project went through prototyping and didn't proceed to the full construction. Next is Francois Rocher, developed an exhibition project and monograph we heard about in 2005, which explored the use of highly speculative self-propelling snake-like autonomous 3D printing apparatus and generative design to system to create high-rise residential towers. The project, although impossible to put in practice with current or contemporary technology, demonstrated a deep exploration of the future of design construction. The exhibition showcased large-scale CNC milling of foam and rendering to create a freedom of building envelopes envisaged. Next is the Dutch architect Jan-Jaap Huyssenaars performative architecture 3D printed building was planned to build by a partnership Dutch companies. The house was planned to be built on the end of 2014, but this deadline wasn't met. The companies have said that they are still committed to the project. The building on demand, or a BOD, a small office hotel 3D printed by the print houses and designed by architect Ana Goidea, has incorporated curved walls and reaping effects on the surface to showcase the design freedom that 3D printing allows in the horizontal plane. Structures, here are the structures and 3D printed buildings. As you can see in the photo. The 3D print canal house was the first full-scale construction project of its kind to get off the ground. In just a short space of time, the camera maker has been further developed to increase its production speed by 300%. However, progress has not been swift enough to claim the title of the world's first 3D printed house. The first residential building in Europe and the CIS constructed using the 3D printing construction technology was the home of Yaroslav or in Russia with the area of 298.5 square meters. The walls of the buildings were printed by the company of Specavia in December 2015. 600 elements of the walls were printed in the shop and assembled at the construction site. After comparing to the roof construction and the interior decoration, the company presented a fully finished 3D building in October 2017. The peculiarity of this project is that for the first time in the world, the entire technology cycle of construction has been passed. Design obtaining a building permit, registration of the building, connection of all engineering systems. An important feature of 3D house in Yaroslav that also distinguishes this project from the other implemented ones. This is not a presentation structure, but rather a full-fledged residential building. Today, is it a home for real or ordinary family? Dutch and Chinese demonstration projects are slowly constructing 3D printed buildings in China, Dubai, and the Netherlands, using the efforts to educate the public and the possibilities of the new plant-based building technology and to spur greater innovation in 3D printing of residential buildings. A small concrete house was 3D printed in 2017. The Building on Demand, or the BOD, the first printed house in Europe, is a project led by the 3D print set for a small 3D printed office hotel in Copenhagen, Nordhavn area. As of 2017, the building is in the final phase of applying fixtures and roofing, while all the 3D printed parts have been fully completed. The building is also the first 3D printed permanent building with all permits in place and fully approved by the authorities. Here are the examples of 3D printed bridges. In Spain, the first pedestrian bridge printed in 3D in the world, 3D bridge, was inaugurated 14th of December of 2016 in the urban part of the Castilla-La Mancha in Alcobendas, Madrid. The 3D build technology was used to develop by Acciona, who was in charge of structural design, material development, and manufacturing 3D printed elements. The bridge has a total length of 12 meters and a width of 1.75 meters. It's printed in micro-reinforced concrete. Architectural design was done by the Institute of Advanced Architecture of Catalonia, or IAAC. The 3D printer used to build the footbridge was manufactured by D-Shape. The 3D print bridge reflects the complexities of nature's forms and was developed through parametric designs, and computational designs, which allows to optimize the distribution of materials and allows to maximize the structural performance, being to dispose the material only where it is needed, with total freedom of forms. The 3D printed footbridge of Alcobendas represented a milestone for the construction sector at international level, as a large-scale 3D printing technology has been applied in this project for the first time in the field of civil engineering in a public space. Next is the extraterrestrial printed structure. The printing of buildings has been proposed as a particularly useful technology for constructing off-Earth habitats, such as habitats on the Moon or Mars. As of 2013, the European Space Agency was working with London-based Foster Plus partners to examine the potential of printing lunar bases using regular 3D printing technology. The architectural firm proposed a building construction 3D printer technology in January 2013 that would use the lunar regolith raw materials to produce lunar building structures while using enclosed inflatable habitats for housing the human occupants inside the hard-shell printed lunar structures. As you can see in the photo, this is the rendering of lunar base printing project commissioned by the European Space Agency collaborations with Foster Plus partners. Next, the dome-shaped structures would be a weight-bearing catenary form with structural support provided by closed-cell structures, reminiscent of bird bones. In this conception, printed lunar soil will provide both radiation and temperature insulation for the lunar occupants. The building technology mixes lunar materials with magnesium oxide, which will turn the moon stuff into a pulp that can be sprayed to form the block. When binding salt is applied, that converts these materials into stone-like solid. A type of sulfur concrete is also envisioned. Tests of 3D printing of an architectural structure with simulated lunar materials have been completed using large vacuum chamber and a terrestrial lab. The technique involves injecting the binding liquid under the surface of the regolith with a 3D printer nozzle, which is a test strap 2 mm 0.079 in scale, droplets under the surface via capillary forces. The printer used was in this shape. Next, the variety of lunar infrastructure elements have been conceived for 3D structural printing, including landing pads, blast protection walls, roads, hangars, and fuel storage. In early 2014, NASA funded a small study at the University of Southern California to further develop. This photo shows the 3D printed section of the lunar base made with D-shaped technology as commissioned by the European Space Agency. The contour crafting 3D printing technique. Potential application of this technology include constructing lunar structures of material that can consist up to 90% lunar material with only 10% of the material requiring transport from Earth. NASA is also looking at a different technique that would involve scintillating of the lunar dust using lower or 1,500 watt microwave energy. The lunar material would be bound by heating to 1,200 to 1,500 degrees Celsius or 2,190 to 2,730 degrees Fahrenheit, somewhat below the melting point in order to fuse the nanoparticle dust into a solid block that is ceramic-like and would not require the transport of a binder material from Earth is required by faster plus partners. Contour crafting and D-shaped approaches to extraterrestrial building printing. On a specific proposed plan for building a lunar and using the technique would be called Sinterhab and would utilize the JPL-6 leg athlete robot to autonomously or telerobotically build lunar structures. Next, we are going to discuss what are the advantages of 3D printing and construction. First, lower cost. 3D printing technology can save up to 60% building materials and 50 to 80% of manpower, which improves work efficiency and helps to reduce the cost. This could be especially applicable and helpful in third world countries, where better homes could be built for less cost. The biggest advantage of 3D printing in construction is its relatively affordable cost. When compared to traditional construction methods, 3D printing requires less time and manpower than the other sources. While traditional construction techniques always involve several men on the job site to complete the project, this is not the case with 3D printing. As a result, it eliminates the need for the unskilled or the skilled workers, and thus expenses like labor costs are considering reduced over using conventional building methods. Next is the environmental friendly. 3D printing significantly reduces the amount of waste material created in production. The right amount of filament is used in creating the models each type, meaning you only use how much material you need. Many of the materials used to print objects can be made from recycled materials, and the created designs themselves can also be recycled. So when it comes to 3D printing, 3D printing reduces the environmental impact of the manufacturing by lowering the waste, energy usage, and use for the space compared to traditional construction. The next advantages of 3D printing is the fast delivery time. In an industry where construction delays can be extremely disruptive and costly, 3D printing offers new opportunities to accelerate delivery and reduce risk by operating 24/7 and by reducing on-site glitches. Hence, delays 3D printers can be reduced construction times by 50 to 70%. And lastly, design flexibility. With the help of 3D printers, architects are more flexible in the shape of their designs. No constraints of technical or structural projects. They can realize even complex forms using non-linear shapes and curved wall, which the conventional construction methods were not capable of building before. 3D printing can create a complex and customized shapes that are difficult or impossible to achieve with conventional techniques. It can also show for more integration of functionality, excuse me, such as insulation, plumbing, or wiring into the structure. Furthermore, 3D printing can also adapt the different environmental and cultural contexts as it can use also a local or sustainable materials and incorporate local aesthetics or traditions. Main application areas. 3D printing started to be used to print tabletop scale models for architecture companies before BIM or the Building Information Modeling. It was an easy and fast method compared to the traditional way, which required more than time and handcraft. In the 1990s, some companies started using 3D printing to produce modular components of full-scale projects. By the 2000s, these applications were in full swing and get to transform the entire industry. And in the past years, application areas of 3D printing has evolved a lot. You can 3D print building components, molds, entire buildings, bridges, or interior designs objects. As you can see in the photo, these are the example of the 3D printed villas in Shanghai by Winsun. So far, the majority applications were smaller scale buildings and especially single-story house, except the Winsun, a Chinese 3D printing company which has developed the first continuous 3D printer for construction. The company printed the first batch of 10 houses in 2013. Using a special link made of cement, sand, and fiber together with a proprietary additive, the printer adds layer by layer to print walls and other components in its factory. The walls are then assembled on site. Using up to 50% demolition waste and producing zero waste, the technology is environmentally friendly. The impact on delivery time is even more impressive. Construction of a two-story 1,100 square meter villa take 1 day of painting, 2 days of assembly with the internal bar structures erected in advance, requiring 3 workmen only. According to the company, 3D printing technology can save up to 60% of building materials and 50 to 80% of manpower, which improves work efficiency and helps to reduce the cost. As you can see in the photo, this is the world's first 3D printed office building by the Winson. Winson is also the first company to print an office building which has opened in Dubai in May 2016. The entire structure was printed using giant cement printer, then assembled on site. The printing took 17 days and was installed only in 2 days. Subsequent work on the building services, interiors, and landscape took approximately 3 months. Buildings or building components are not the only areas of application. You can even print a bridge in metal. The most famous project is the one of the Dutch start up to the up MX3D, who is the 3D printing a fully functional stainless steel bridge to be installed on one of the oldest and most famous canals in the center of Amsterdam. MX3D equipped industrial multi-axis robots with 3D tools and developed the software to control them. What distinguishes this technology from a traditional 3D printing methods is that the printing is done by 6-axis robot arms. These techniques gives the design flexibility for architects and engineers and has a huge potential to reduce the amount of material needed to make large structures. And the printing of the pedestrian bridge is scheduled to be finalized early in the 2018. Another application of 3D printing in construction is a 3D printed molds, which gives freedom to architects and designers to make their marks by unique shapes and forms. One of well-known systems in this area is the prefab system, a construction technique operated by Australian European contractor Laing O'Rourke, a giant robotic 3D printer with a build volume of 30 by 3.5 by 1.5 meters. Prints large molds from specially designed wax. Those molds are then used to cast concrete panels in the double curved walls panels London's Crossrail project. The technique is also more eco-friendly and less wasteful than conventional mold making technologies. Free-fab wax molds can be melted and the wax reused again and again. The first photo shows the London's grocery project, while the second photo represents the 3D printed wax models. 3D printing technology is evolving fast. We see impressive examples in construction industry. However, there is still a long way to go for most building constructions. First, the laws and authorization must be modified according to this new technology. Also, 3D printers must be movable to be used anywhere. In short term, we can expect more and more building components to be built with 3D printing as well as printed molds. It's sure that the building of future will not look like the ones of today. Architects, engineers, and workers of 3D print architects, engineers, and workers will have to adapt to this transformation and learn to master well these techniques of 3D printing. Even though there are still some challenges to overcome, we can still be positive about the future of construction 3D printing. So that concludes my report. Thank you for listening and watching, guys, and have a good day.